We're back with the Hagström PA-200. So apparently the spring reverb is not working either, so we'll have to fix that too. You can apply reverb to all of the 6 channels by turning this knob from its off position, and you increase the contribution to each channel by turning it further clockwise. Okay, so let's quickly go through how a spring reverb works. It is essentially 2 transducers connected together with a spring. So the concept is the same as for a dynamic speaker element and a dynamic microphone. So the input works in the same way as a dynamic speaker element, but instead of moving the coil back and forth, it moves the spring back and forth. The output is the same concept but reversed. When the metal core moves inside the coil, it induces a current that you use as the output signal. So if the coupling between the input and the output would be a rigid metal bar, you would basically have a one-to-one mechanical transfer of the audio. But instead you couple the input to the output with these springs, which introduces some irregularities and reflections in the signal transfer, thereby causing this reverb-like sound. So we'll start by checking if the reverb module is powered properly. The power comes from the amplifier module, it's the same transformer. So you probably noticed that this knob has been replaced, and apparently this replacement knob is not very suitable, since their shaft is way too short. So the screw inside the knob is barely gripping the edge of the shaft. So we'll have to use a different kind of knob, the ones that grip the entire shaft. Now here's supposed to be a metal plate to shield the reverb electronics from the mixer, and that's because the reverb electronics is extremely sensitive to interference because of the very low output signal of the reverb tank. So there will be some interference that is not supposed to be there. Okay, I think we'll remove it from the case before we start measuring. The voltages seem correct. I can hear the music in the springs, so the signal is definitely reaching the reverb module. So the failure is probably somewhere on the way back to the mixer. Okay, so we'll feed it with a constant sine wave instead, so it will be easier to probe and see where we lose the signal. Okay, so now we're feeding the system with a sine wave. So let's measure on the transformer right before the spring. So here we have a quite strong sine wave, 20 volts peak to peak, and we can vary the amplitude by adjusting the reverb intensity knob, and it goes all the way up to 40 volts peak to peak. Let's measure the output. So it seems we get no signal whatsoever on the output of the spring. So here we have the 2 wires coming from the output. So this solder joint does not look that good. Let's resolder it and see if it solves it. So we do get a signal now. It is very weak though, 8 millivolts peak to peak. But the output voltage of a spring reverb tank is usually very low, so it's probably right. Nothing yet. The signal needs to be amplified, so let's see if that works. So this is the reverb volume potentiometer. So we should be able to look at the output on the center pin. So there we have an output signal of about 350 millivolts peak to peak maybe. and it reacts when I tap the reverb tank, so it's definitely the output. Okay, so then it seems like the entire reverb module is working, and that there's something wrong with the reverb signal reception in the mixing console instead. So it seems that the output of the reverb module goes to this PCB, we have a solid backplate for the PCB to shield the signal. That's very nice. So it seems that the signal goes into a component that's inside this wooden block. Oh, it's an optocoupler. So on the top we have a light source, and on the bottom of this wooden well we have a photoreceptor. So optocouplers are usually used when you want to galvanically separate two parts of a circuit. So you can transmit a signal between two parts of a circuit without having any electrical connections. Okay, so let's see if there might be something wrong with the lamp. Okay, let's turn it on and see if the bulb lights up. It doesn't, and there is no voltage across it either. So it seems that the signal comes from the reverb module, it goes into this photoreceptor here, and depending on whether or not this light is on, it is passed through the photoreceptor and is mixed together with the clean signal. So as I understand it, this optocoupler acts as a switch. Okay, so let's just see if we get some reverb if we shine a light on the photoreceptor. So the light bulb is connected to ground and to these blue wires. So if we follow these blue wires, they go to this connector. So I can't find any voltage generator connected to this node, so the power must come from somewhere else. So I guess you have to have the reverb selector foot pedal connected to be able to use this. And here it is. So let's see which two pins on the connector is shorted together when you push the reverb switch. So now it's connected to 1 and 3. Okay, so it connects 1 and 3 together. That would mean that the blue wire connected to the light bulbs is connected to the red wire. So we should have 12 volts on the red wire instead. But there is nothing on the red wire either. So the red wire is connected to the PCB here. And if you look at the back of the PCB, you can see that it's directly connected to this green wire here. And the green wire is connected here. It's on the output of this full bridge rectifier. And the AC input of this full bridge rectifier comes from the outermost winding on this mains transformer. So let's do some measurement here. Okay, so now we're going to measure the output of the full bridge rectifier, which should be a DC voltage. But we get nothing apparently. Okay, let's take a look at the input of the full bridge rectifier. Okay, so at least the transformer is working. So it seems that there's something wrong with the full bridge rectifier. Okay, let's remove it. I don't have an identical replacement, but I have one with similar specifications. That should suffice. Okay, let's turn it on and measure the output voltage now. There we go. Okay, let's see if the light turns on. It does. Okay, now let's make sure the reverb works. Seems to work. Now I must say that the cause of failure here was a bit surprising. I did not expect the power supply for the light bulbs to be the cause of failure for the reverb.